what we're going to be doing today and Wednesday is very, very crucial. And of course, I advise, you know, I need you to listen and be focused. Like I said, okay, so let me first say this. In the exam, I'm actually as part of exam document. I'm also going to attach useful tables, statistical tables that will be needed uh, as far as this final exam is concerned. And not only that, I'm also going to attach this. Uh, I don't know if you can all see this guy now, right? So this give formula for table, for different kind of hypothesis testing that you may want to perform. And at the same time, the only one that is not listed here is the one for variance and the one for proportion. That is the only one that is not listed. So if I were you, the one for variance and the one for proportion, I would advise that you actually uh, go over that as well. So like I said, these will be attached to your exam documents. Okay, so let me first say that your exams, you're going to have 3 short answer questions. I'm going to say that again. 3 short answer questions, and the 3 short answer question will revolve around what you did in chapter 8, 9, and 10. I think with the majority on chapter 9 and 10. So I want to confirm to you, in the final, there's going to be question on hypothesis testing. There's also going to be question on confidence interval. So, and in class, I've walked you through hypothesis testing that has to do with, I'm going to start from this table so that you'll be able to understand what I mean. Okay. And I also want you to walk through this, you need to check your notes. You need to revise what you've done before. And let me also say this is being recorded. Okay, this is being recorded. So I'm actually going to publish this at the end of the day. Now I'm going to start with I'm going to walk you just through this table right now. Okay, the table has to do with the hypothesis testing formula. Okay, so when you take a look at the number one, when you take a look at this guy here, okay, and I need you to pay attention whenever you are giving hypothesis testing that has to do with mean, okay, and the standard deviation is known. Take a look at this guy, okay. The standard deviation is known, okay. When the standard, I think the chart came in, I don't know, the person said, we need to know how to find the p-values. You don't necessarily need to know how to find the p-values. And that was why I gave, an option of a critical region. Okay, I don't know if I've answered the question. Somebody who chat with me, okay? So you don't necessarily, I think I also said that in the class, you don't necessarily need p-values. You can also use critical region to take a decision, just like the way I've demonstrated in the class. Okay, so when you take a look at this guy now, you use this when you are testing hypotheses about mean. You're dealing with one population and the standard deviation is known. Standard deviation is known. When I say standard deviation is known, I mean the population standard deviation. not the sample this time around, the population standard deviation. And you are testing hypothesis about any of these. Of course, you're actually going to check from a Z table. If you take a look at what you have here, okay, this go for this go for this, and this go for this. I told you the other time, okay? Now, somebody said the sample size, let me check, a message came in. Somebody that doesn't sample size have to be bigger than 30. Now, this is the situation. When the population standard deviation is given, okay? When the population standard deviation is given, irrespective of the sample size, you can make use of Z. There's no problem, okay? But when the population standard deviation is not given, but the sample size is at least story, you can still make use of Z. I'm going to say that again. There are two conditions under which you can use a Z test. It's either the population standard deviation is given, okay? If it is not given, if the population standard deviation is not given, but the sample size is at least story, okay, we can still use Z-test. Then what is the condition to use? Somebody said, will we get the Z-score and T-value table for the exam? Of course, like I said, you're actually I'm going to give you tables. You're actually going to get that for the exam, okay? It's going to be part of this exam. Apart from this that I'm displaying right now, I'm also going to attach the needed statistical tables. You did not need any, you don't need to come with any table. I'm going to say that again. You do not need to come with any table, okay? I'm going to provide, and it's going to be the same as the one in the textbook. It's going to be the same as the one. Somebody said, where will the exam be held? Of course, in your class. The exam will be held in your class, in that same class venue. Okay? And this, so it's going to be somebody said, asked about two sheets. Two sheets, just like the one I tolerated before. Two sheets, but if you are using two sheets, it's going to be one-sided here, one-sided here, or you use a single sheet, double-sided of notes. Okay, so I'm going to quickly go because of my time. I think I'm going to answer a question later, but now, what of in a situation where I think I just demonstrated now, when do we use a Z? We can use Z in two conditions. It's either the population standard deviation is given or the sample size is large. And how large is it large? It has to be at least story. Then when do we use a T? Then when do we use T? We actually use this guy here when the population standard deviation is unknown and the sample size is very small. So very small means less than 30. That's what I mean. Okay. So that is what I mean. Somebody said it's critical region and critical and rejection region is same thing. Yes, they are the same because they are the region. They know a rejection region is called critical region because that's a region where you're going to reject. That's why it is called critical region. So critical region and rejection region are the same. Okay, somebody will shout with me. Critical region and rejection region are the same. Okay. Okay, so now, like I said, when the population standard deviation is unknown and the sample size is small, and how small is it small? It has to be less than 30. Okay, then you're actually going to use, this formula I'm showing you right now. And the condition to take, it means you're going to check from the T table. And depending on the nature of the alternative, that is that. Okay? Now, I need you to take a look at the way I explain that guy right now. This is very, very crucial. Now, another thing I want to talk about is what if in a situation where we're dealing with a two population and we want to test for the equality of means. Okay, want to test for the equality of means. Now, take a look at this situation now. When do we use Z? For that situation is when the two population standard deviations are given. There's a difference between two population standard deviation and the sample standard deviation. When the two population standard deviation are given, you're actually going to make use of Z. And don't forget, you're going to be checking from the Z table. Okay, if you compare this guy with this guy, it's the same. Okay, Z, whether you are dealing with the one population or two population, is always going to be the same. I need to take a look at that. It's always going to be the same. The critical region or rejection region, always going to be the same. So I need you to take notes of that guy now. Okay. Now, another thing that I want to talk about is what if in a situation where the two population standard deviation are not given. If they are not given, that is going to, there are two things that will determine what we're going to do. Number one, if they are not given, do they say that, do they assume them to be equal? Okay. If they are not given and they are assumed to be equal, then you're actually going to use pool variance. You need to first get a pool variance. Okay. And you know, the SP squared, whatever you get here, you find the square root, that's what you're going to put here. And that is always going to be T. That is always going to be T. Okay. And of course, the same decision, if you compare this guy with this guy here, you're actually going to see that they are the same. If you are running a t-test, whether for one population or two population, is the same rejection region. It is the same critical region. If you're also dealing with Z, whether you're dealing with one population or you're dealing with two populations, it's also going to be the same critical region. It's also going to be the same rejection region. Now, I just walk you through a situation now where the two population standard deviations are not given, but they are assumed to be equal. But what if in a situation, okay, we want to go into another situation now, okay, they are not given, okay, but they are not assumed to be equal. Even though they are not given, but they are not assumed to be equal, okay, it's still going to be t-test, except that the way we're going to find the degree of freedom will be different. Now, what is the difference between these two here? If I want to, determine this guy here, I need my degree of freedom is going to be N1 plus N2 minus 2. If I want to check from the table in a situation where the population standard deviations are not given, but they are assumed to be equal, the degree of freedom is going to be N1 plus N2 minus 2. But what if in a situation where they are not given, but they are not assumed to be equal, you need this guy here to figure out the degree of freedom. Okay, don't forget, if you want to check from the T table, you check under certain degree of freedom. I think I want to start at attending to, like, if you need clarification of what I just explained right now. Is there anyone who need clarification on this? I want to confirm again if everyone is still hearing me. Can somebody confirm if you're still hearing me clearly?
I can still hear you.
I can hear you.
Thank you so much.
You can still hear you.
Thank you for confirming that. So, like I said, this particular table will be provided in the exam. I'm actually going to attach this particular table that I'm showing you right now. I mean, the whole of this will be attached. Okay. So in the exam, I'm actually going to attach. Let me confirm the table that I'm actually going to attach. Okay. I'm actually going to attach this particular table. I'm also going to attach the Z table, the T table, the F table, the chi-square table. I'm going to say that again. I'm going to attach this table. I'm going to attach the Z table. I'm going to attach the T table. I'm going to attach the F table, and I'm going to attach the chi-square table. All of that will be attached to the exam document. Okay? Somebody said, do we have access to it before the exam? It's in your textbook. Now that I'm confirming that to you, if I were you, start understanding them. It's in your textbook. This table 10.3, Z table, T table, F table, chi-square table, they're all going to be attached to the exam document. I'm confirming that right now. Okay? So somebody said the only one that is not here is variance and proportion that you are going to figure out. I'm not going to attach that. Okay? You should be able to know. Maybe that is part of what you're going to write in your cheat sheet. Variance and proportions. Okay? Now, what I've been displaying, what I've been talking about here. Now, and I want to go to the last one here on the table. You remember we did something about period, right? Situation where we actually collect observation from the same participant at two different occasions. We're going to conduct what we call a PAT test. Don't forget the degree of freedom is always going to be n-1 for the test. Okay, don't forget the way. So this is the formula. And all of this. Take a look at this guy. Take a look at this guy. Okay. If you take a look at the other one here too, they are all the same. The only difference between them is the degree of freedom. The degree of freedom. The degree of freedom here, n-1. The degree of freedom here is this guy here. The degree of freedom here is this guy here. Okay. So now, let me see the other one with C. The degree of freedom here is n-1. Okay. So I needed to take notes of all of that. So like I said, this table is in your textbook. Okay. This particular table is in your textbook. So the tables that I'm actually going to attach to the exam document, they are in your textbook. Another thing that we advise that you should write in your cheat sheet. You know, we just talked about hypothesis testing now. What about confidence interval? You also need to write the test, if I were you, in your cheat sheet, write the confidence interval, the formula for the confidence interval. For one population, somebody said is T that different from T. They are the same. If you are referring to this and this, they are the same, except that the degree of freedom that you're going to be checking from is just the degree of freedom. So that is just it. It's just the same T, but not the same formula anyway. Okay, you understand here? The formula here is different from the formula here. Okay, it's even from the formula for T here. Does that make sense? But there's T. Okay, so I needed to take note of all of that. Okay, now I'm going to go into the confidence. I'm going to go into the other one now. So, like I said, review of this, review the confidence interval. You know, my focus today is to walk you through, the short answer question in the that will come in the exam. That's going to take 60%. Okay, like I said, question is going to revolve around hypothesis testing. Okay, confidence interval. Hypothesis testing and confidence interval. That was why I gave you a practical assignment on the hypothesis that will focus on the hypothesis testing and the confidence interval. Now, hypothesis testing, don't forget the one for variance. Don't also forget the confidence interval for all of that. Okay, so I'm going to, move to some questions right now. Give me 1 second. I'm going to move to some question right now. Now, if you take a look at this question here, okay, this is like an exam question. This is for my previous exam question. Okay, now we take a look at this guy. They're talking about, and they gave you a table, and they've already helped you to compute the difference. Of course, you know, this is going to be a PRT test. If I'm going to give you something like this, do you know why I computed the difference? Because the observation is too large, is much. You see the observation? 15. Okay. So you see the difference? Okay. And when you have the difference, what is the question? Please pay attention to this question. If I were you, I needed to pay attention right away. Okay. Like I said, you use T table for all those one that has to do with T. We use T table. Somebody share with me right now. T table for everything that require the use of T. The only difference is going to be the degree of freedom. Okay. Now, I need you to pay attention to the question here. Find the point estimate for the population mean of the peer difference. Okay. Now, which is the mean of the peer differences for the sample data. Find the margin of error. Compute the 95% confidence interval for it. How do I solve that question? You know, when you take a look at this guy, of course, I'm going to allow you to use a scientific calculator in the exam. You need to find the mean of this guy. We need the mean of the difference. You also need a standard deviation of the difference. So if you come back here now, excuse me. Now, what am I doing here? Okay, what am I doing? I'm finding the mean of the difference. Adding all the differences together divided by n. The mean of the difference gives me this. Is there anyone in this class who doesn't understand how I got that guy out? Okay, this is the formula. I add up the differences, okay, and I divide by the number. Take a look at that guy here. You take a look at this guy here. You see that? All this guy here, the difference, add them up. And put into consideration negative, positive. You know how you add integrals in middle school. Don't forget that. You don't forget that. Okay? Or somebody chat with me. I believe T is an alternative way to compute the T statistic for the difference it means. I will advise that you follow what I'm presenting, okay? I will advise. I'm going to go back to somebody is confused in the chat about this guy here, about this guy and this guy. What is the difference between them? No difference. All anywhere you are checking for T. But what made the difference is this guy. I told you what made the difference is this guy here, the degree of freedom. The degree of freedom. That's what made the difference. You see that? The degree of freedom is different depending on the text. You have to understand, because if you want to go to T-table to check, you are checking under degree of freedom and the level of significance. Does that mean if you take a look at all of that, they are the same? Or the critical region here is the same as this? Is the same. But what you are checking is different. Please take notes. The same thing also applicable. Okay, so I don't know whether the person get it, person that share with me. Oh, okay. So that is just it. I'm happy that you get it now. It's the same. It's just the degree of freedom. So the critical region for anything that has to do with C is the same specification. The Z for any for the critical region for anything that has to do with Z, whether one or two population, is also the same. Okay, so I'm going to go back to the question I was solving the other time. Because of my time. Okay, they ask you about the mean. We've gotten the mean. This is the mean of the difference. See the mean of the difference. And they ask you about the margin of the error. What is the margin of error? Do you know that in a confidence interval, if I want to write confidence interval for this guy, is just going to be this plus or minus margin of error. The margin of error is the whole of this guy. That is the margin of error. So what if they ask you to find the margin of error? It is that part. If you want to find the margin of error, you need a standard deviation of that difference. This is what I'm doing here. You can decide to use your calculator. Okay, the standard deviation becomes that. Then I need to go to T-table, check for T alpha over 2. Okay. Now your alpha is 0.05. If you divide the 0.05 by 2, that would be 0.025. Then what is going to be the degree of freedom? I told you for PRT test, the degree of freedom is going to be n minus 1. So 15 minus 1, 14. So I'm going to go to the table, to T-table, check 14 on, or check under the degree of freedom 14 and is 0.025. That will give me this guy. That is what I put here. Okay, so this guy now is representing this guy here. See that? Then if I plug in what I got here, then the square root of the sample size, then I'm actually going to get my margin of error. Okay, my margin of error is 7.095. Do you know that the moment I get my margin of error, it's going to be easy for me to construct the confidence interval, because all what I'm just going to do is to add the margin of error and subtract the margin of error, and I'm actually going to get two results. So take a look. Give me 1 second. So take a look at this guy now. Okay, so I'm gonna. Do you see what I've done now? I'm just gonna do plus or minus to that, and I've got it. This is my confidence interval. I'm done. I'm done. The review, this document is on Canvas. You can check the Canvas. Okay? Is there anyone who doesn't understand that? That's super easy. Is there anyone who need clarification on that? I want to see if you can hear me again. Can somebody talk? Can you still hear me?
We can hear you.
Thank you so much. Thank you so much. Somebody said, where did you get 0.025? Okay. Look at it. Alpha over 2. I told you the other time, anytime you are dealing with the confidence interval, it's always going to be alpha over 2. Your alpha is 0.05. So what is 0.05 divided by 2? It is 0.025. So you're always going to divide your level of significance by 2. Okay, thank you too. Okay, now that is done, then I'm going to go to another one. Let's take a look at this guy now. Okay, a study was conducted and two types of engines, A and B, were compared. 50 experiments were performed using A, 75 using B. The average gas for A was this, and therefore assuming population standard. Okay, now I need you to focus on this question now. They gave you population standard deviations. You see that? They gave you population standard deviation. I told you anytime they gave you population standard deviation, you're going to use z-test. That is going to be z-test. Okay, that's going to be z-test. Because we're giving population standard deviation, that is going to be z-test. Okay, now take a look at this now. If they wanted to perform a z-test on this, okay, I'm collecting my data here. Okay, now my mean, my standard deviation. Okay, if you take a look at that, the first question, let me go to the first question. The first question for find the point estimate of the difference. So the point estimate of the difference, just for you to subtract the two means given, that will give you -6. You're giving for mean of A, mean of B, the mean of A 36, the mean of B is 42. Okay, I need you to take note of that. So the mean of the difference actually gives -6. Now, what about the margin of error? If I want to get the margin of error, okay, you know, the margin of error is just going to be your Z, what you check from the table, okay, multiplied by this guy. You remember in the formula, we know in class, X bar 1, if I want to construct confidence interval, okay, minus X bar 2 plus or minus Z alpha over 2, okay, then square root of sigma 1 squared, you remember, over n1, okay, plus sigma 2 squared over n2. The whole of this guy is the margin of error. Okay, so which means I'm actually going to check from Z table, okay, given the level of significance. Okay, give me 1 second. Okay, so given the level of significance, and that is going to give me 1.96. Okay, and this guy here, okay, you of course you actually have already, you know, if you take a look at this guy, I've already done that to get this, which is what you have, which is what I'm doing here. If you take a look at, give me 1 second. Yeah, which is what I'm doing here and what I'm doing here. Okay, that's what I'm doing here, just calculating them separately. You can also calculate them in your own way too. There's no problem at all. Okay, so at the end of the day, you're actually gonna get that guy. So super easy. Okay, and the moment you get your margin of error, all what you just need to do is subtract and add to get the confidence interval. Look at that. I subtract, I add, and at the end of the day, this is what I got as a confidence interval. Okay, you see that now? That's super easy. Somebody shout with me. Wouldn't the sample size for B be 75 as given in the question and not 50? So let me see what you mean. if you're talking about this, okay, I use 50-50, right? Let me see whether they mention, let me see. Oh, thank you for that. So this was supposed to be 50. Thanks for catching that. That's supposed to be 50. Okay. So because if it is 75, I'm going to use 75. So, okay. So thanks for catching that. Okay. So give me 1 second. I'm gonna, the final exam is gonna be so easy for you. I can assure you that. Okay, it's gonna be so easy. It's gonna be so easy. Now, let me go into the next question. Now, take a look at this question now. This is hypothesis testing on proportions. Okay, if you take a look at what we have now. Okay, so here you were given a college claim that more than. Now, I need you to pay attention. More than 94%. Okay. Now, the greater than is going to be here. I put this guy here so that you will be able to know. I told you the other time, more than, right? It's always going to go into the alternative. Okay. What is the opposite of more than? Opposite of more than is less or equal, but, okay, even though some textbook tolerate this, I always want to tolerate equality sign. Does that make sense? I always want you to put equality sign in the non-hypothesis. Okay? Always put equality sign in the non-hypothesis. Okay? I know that the sign in the alternative is going to be the complement of the one in the null, but in this class, I want you to be putting equality sign. Okay. If that is taken, don't forget equality sign. Somebody shouts, when do you flip the sign of the HA? Let me tell you this. You don't flip the sign of the HA all the time. Always take note. Under the HA, you're always going to say that you have this guy, nothing more. You can never have. So if you have any of these, your HO, don't forget, please. Your HO is still going to be this guy. Your HO is still going to be equality sign. Now, let me give you this example now. Let's say for instance, in the question they mentioned at least, right? Let's say in the question, let's say they mention at least, right? I think I'm going to use my remaining time to work on that because I realized that I'm going to stop my share now. Give me 1 second. And I'm going to share my whiteboard because I noticed that is convincing some. Now, I'm going to share my whiteboard now. Please pay attention to this. Let's say in a question they mention at least, right? What is at least? At least means this, right? At least means that, right? If you want to write your alternative based on this, you're actually going to write complement of that. What is a complement of that? It's less than. Why your norm is still going to be quality sign. I don't know whether I've answered this question now. Let's say they mention in the question at least. At least means greater or equal, right? If you want to go to the alternative and write the alternative, you're going to write the complements. complement. The only time under which you need to write the complement of what they gave in the alternative is when they give you at least or at most. Now, I'm going to give another one now. Let's say, for instance, let's say in the question they mentioned at most. What do we mean by at most? Mathematically speaking, is less or equal to. Okay? It's less or equal to. What is the complement of this guy? That would be greater than in the alternative. But the null hypothesis is going to be equality sign. The only condition under which you're going to talk about the complement, okay, to be put in the alternative is when they mention at most or at least. I don't know whether you're getting that now. Somebody shout at me right now. Let me see what the person is saying. Is there any theoretical reason for using less or equal to according to some textbook and not others? You know, there's a lot of reason why we don't tolerate the use of this. Why we don't tolerate. Give me 1 second. I'm gonna, I normally I told you that the null hypothesis is always going to be this. If you go and decide to put this or this in the null hypothesis, you have changed the definition of the null hypothesis. What is the null hypothesis? Hypothesis of no effects. Hypothesis of no effects. That is what the null hypothesis means. So the null hypothesis is more or less like a statistical, like equal to this. Do you understand now? So when something equal to something, it's like you are trying to say your observation is the same thing as reality. I told you the other time when we are testing hypothesis, we want to test, is there an agreement between observation and reality? If there's an agreement between them, then the null hypothesis is true. And that's why it's always going to be equality sign. Even though some textbook can put it less or equal to, greater or equal to, they just put it in for, for emphasis. And this is the reason why they are putting it. The reason why they are putting it is this. I'm going to show you now. Like, if the alternative is this, they put this for you to know that is complementing each other. That is just the essence. It's just for complement. That is why some textbooks are putting that. But in the actual sense, the null hypothesis is a hypothesis of no effects. It should have equality sign. I told you what we tolerate, okay, all the time. In the alternative, please don't forget either this or this or this and nothing more in the alternative. If you write in your alternative, if you write this or you write this, you are wrong. In your null hypothesis, if you write this or write this, you are wrong. Your null hypothesis all the time must have equality sign. Is there anyone who needs clarification again? Like I said, if you go over what I put in the material for today, that is actually going to take 60%. That is going to take 60% of the final question on hypothesis testing and confidence interval. So if I were you, start studying them. Hypothesis testing for mean, hypothesis testing for proportion, hypothesis testing for variance for both 1 and 2 population, then also study their confidence interval. Those are stuff that you see in the short answer question in the final. What I'm going to do tomorrow is to review chapter 4, chapter 5, and chapter 6. Somebody said, do we need to prove? I think a chat came in. Somebody said, do we need to prove any assumption, or we can just do the test? That depends on the question given. In a particular question, I can say, okay, verify the assumption or not. Okay? So somebody can, it depends on the question. But what I will advise you to do is check for the assumptions of all the tests that we've done and of the confidence interval. Now, in the multiple choice, okay, the multiple choice question is going to be 15. Okay, and I'm going to talk about that tomorrow. That will be 15 multiple choice. Initially, I wanted to set 20, but 15. Okay, 15 multiple choice. And let me tell you this, no any rigorous calculation. Except, I told you, chapter 4, chapter 5, chapter 6. Okay, here, try and understand how to find the mean and variance of a particular distributions. Okay, I'm going to review all of that tomorrow. But chapter 4, that is where you need your calculator. Okay, chapter 4 will be similar to something that we did in exam 2, where you have joint distribution, where I'm going to ask you to find the expected value of y, the variance of y, the covariance, and stuff like that. There's not going to be any serious work in chapter 5 and 6. It's just reading and know how to find the mean and variance of the both discrete and continuous distributions. I'm going to say this again. There's not going to be any serious calculations in chapter 5 and 6. Of course, you can write notes on a paper. Of course, you have a 2 sheets yourself. So she normally share with me right now. Okay, but I'm actually going to walk you through chapter 4, 5, and 6 tomorrow. Like I said, there's going to be 15 multiple choice. But let me tell you, 10 questions in the multiple choice will actually come from chapter 4. 10. Okay? 10. And only 5 questions will come from chapter 4 and 5. I mean, chapter 5 and 6. And somebody says, is the final going to be online? No. The university schedule final exam at the beginning of the semester. Instructor only has our flexibility when it comes to midterm exams. But when it comes to final exam, university schedule the final exam at the beginning of the semester, and it has to be in person. So I don't know if I've answered the question. Somebody that chats with me. Okay, like I said, also said we allow one piece of paper front and back. Of course, it's either you use one piece of paper front and back or 2 pieces, one-sided. It could be two pieces of paper, one-sided, or one piece, then you write at both sides. No. Somebody said, would there be a multiple choice covering chapter 1 to 3? No. Please, I need the person to listen again. Chapter 4, 5, 6. There's going to be 15 multiple choices question. 15 multiple choice will revolve chapter 4, 5, and 6. 10 questions, 10 out of 15 will come from chapter 4. Only 5 We come from chapter 5 and 6. Only 5 questions. We come from chapter 5 and 6. And in chapter 5 and 6, you need to be able to understand how do we compute the mean and the variance of probability distributions. That's all. There's no serious calculations, but there's going to be calculations in chapter in chapter 4. I said you're actually going to have 15 multiple choice questions, 15 multiple choice. And I'm going to walk you through all of that tomorrow. I'm going to say this again. Chapter 4, 5, and 6. We have 15 multiple choice. Chapter 4, we contribute 10 questions out of the 15. Somebody said there is class tomorrow. I don't know what you mean. We don't have class on Tuesday. But what I know we have on Tuesday is an office hour. So if that is what you mean. But on Wednesday, class is also going to be aired remotely. So the next time I'm going to see you in person is going to be the day of exam. And this particular preview is being recorded. I'm going to share that with you at the end of the day. Okay. Is there any question before I go? My time is up. Is there any question before I go? So before I go, they are, in the final, you're actually going to have, 3 major questions, short answer that will focus on hypothesis testing and confidence interval. I need you to read a hypothesis testing confidence interval for 1 population and 2 population, read for the mean, read the variance, read proportions. Now, there's going to be 15 multiple choice questions. 15 multiple choice questions. 10 questions will revolve around chapter 4. 10 questions out of the 15 multiple choice. Why 5 we only come from chapter 5 and 6? Somebody said, I have a couple of questions. Can I speak? Go ahead.
Hi, so I was wondering for the question you showed us, are we going to have to calculate a standard deviation from a sample data set on our own during the test?
Or whether you're going to calculate the sample standard deviation from the sample during the test? Is that what you mean?
Yeah, because in one of the problems you had to like get the mean and sample deviation on your own, but in a lot of the practice problems it just gives you that information.
Oh, I got what you mean. Actually, I'm gonna do it in a way. It's gonna be something you can finish within 2 hours. You remember before I wanted to set 20 questions, but now I reduced that to 15 questions. But I will advise that you should prepare for understand situation where you are given data set, you're going to compute yourself, and also understand situation where you are giving. Does that make sense? So because of course I'm going to allow you to use a calculator in the exam.
Yeah, I was going to ask you about that also. Like, what kind of calculator are we allowed? Is it just like a regular scientific calculator?
Exactly. Regular scientific calculator is what is allowed.
Okay, and do we need to know how to calculate the type 1 and type 2 errors? Because we didn't really go over that.
It's not going to be part of this exam.
And then I just had 2 more questions. So for the extra credits, you said to like email you after the exam of how many we have. So each time that I earn an extra credit, was that 1 or 2 points of extra credit?
Okay, so each time you answer my, when somebody answer my question in class, I normally mention that you have 1 or half. Okay, somebody could have 1, the maximum is 1, and somebody could have half points. So what I need you to do is when you are done with your final, okay, I'm going to send a message, through the announcement section, asking those who have earned extra credit to send me a message about how they want to spend it. And they also need to tell me how many times have they answered my question in the class and I have a way to reconcile that?
Okay. And then my final question was if you had do you have any like extra time to just look over our project to make sure we just have everything, or should I go to office hours? Because I kind of have a conflicting class during your office hours.
The office hour is going to be because after this, I'm also going to be having another class. So,
Mhm.
but can you quickly ask about
Yeah,
what do you want to
so
ask about?
well, we did our experiment and we have a confidence interval and we have like the hypothesis testing, and then we have like our conclusion based on our results. Is that pretty much everything that we need? Or do I
That
need to
that
do
that really
anything?
that really makes sense to me. You know, I deliberately gave that practical assignment because I know the largest percentage in the exam, in the final, is actually going to be from that area.
Mhm.
So I deliberately introduce it to that area so that you're actually going to understand that area, in the preparation for the final. So all what I just need from you is, of course, follow the step. If you want to conduct hypothesis testing, right? You know the way, the procedure, right? You're going to start from the formulation of hypothesis to the test statistic to where you have your rejection region or your p-value, then your decision. That's all I need.
Okay, so do we have to get a p-value since we're using a t-test? There isn't really a way for us to get a p-value easily.
I'm okay with just rejection region,
Okay. Yeah,
yeah,
so we're
because
good.
I know getting p-value with a t may be tedious because we don't use software in this class. If we're using software, it would have been very, very easy. So that's why I'm flexible. So I allow you, taking decision using rejection region.
Okay, sounds good. That's all my questions. Thank you.
You're welcome. Okay, somebody said we have time this week to ask a question about practical assignment. Of course, you can ask me any question about practical assignment or whatever in the office hour. My office hour is aired tomorrow. Okay, so that's no problem. Okay, if you want to ask question on anything, I'm actually gonna be on ground. Okay, somebody said, what's something student commonly get point mark out of for in regard to practical assignment? If you don't follow the step, the step is and the way you conclude is very important to me. Your conclusion has to be specific, not a general conclusion. There's a reason why you are conducting that research in the first place. So if you want to conclude, let your conclusion reflect the reason why you are conducting the research. So if everything is actually spelled out, if you follow the standard statistical procedure, you should be fine. You should have the 100%. And you are not only going to do hypothesis testing, you're also going to, for instance, if you do hypothesis testing on a problem, that same problem, you also need to do confidence interval. For every hypothesis testing, there exists confidence interval. You're also going to do the same for that. Okay, this way I'm actually, okay, somebody
I have one
said,
more question.
go ahead.
For the practical, is it okay if we have a teammate that's in the Unite version of the class, or do they have to be within the actual course?
Okay, can you say that again?
So my partner for the practical exam takes this course on the Unite front. So they're not in our technical course, but can I still do the practical exam with them?
Yeah, that's okay.
Okay.
Yeah. So somebody said, will our assignment 10 get dropped if we don't submit, given that we have completed other homework since the lowest score get dropped? Yes. You know, if you decide not to do assignment 10, so which means you've already done 9 assignment, that's no problem. So which means you have automatically dropped that assignment yourself. Because what I wanted to do before is, look at your 10 assignment, then drop the one with the lowest score. But if you only complete 9 and you decided not to complete assignment 10, there's no problem. Okay, which means you've already dropped it yourself. Okay, this way I'm actually going to stop today until on Wednesday. I'm actually going to come your way. Before I go, somebody say if we are working in a group for the practical assignment, is everyone supposed to submit the assignment, or it is fine, everyone has to submit? If you are working in a group, everyone has to submit, but you got to make sure you put the name of others in your submission. Okay? Everyone has to submit individual, even though you work together, you have to submit individually, but on your submission, I also need you to indicate the names of your other members of the group. Okay? Thank you too. Well, make sure you all stay safe and have a good day. Bye for now. See you also remotely on Wednesday. Bye for now.